Okay, part D. A second train, make sure we got some sound here. Yep. Okay. A second train B travels north from the origin station. Okay, so now we've got a train going back and forth this way. We've got a train going this way. At time t, the velocity of train B is given by this formula. So instead of a table, they're giving us a formula for the velocity of train B. So we know the velocity of train A, at least at some times we know the velocity of train B at any time. Time equal 2. Train B is 400 meters north of the station, so I would write that down. The position of train B, use the white one over here. The position of train B at time equal 2 is a positive 400 because we are 400 north of the origin. Find the rate. In meters per minute, that's a big clue, meters per minute, that's a velocity, at which the distance between train A and train B is changing at time equal 2. So at the moment of interest, now they are forcing you to remember a part back here, part C, where they told us that the position of the train at time 2 was 300, train A. You have to remember that. But again, you have a sheet that everything's laid out in front of you, so that kind of helps. So you've got one train sitting here, 300 from the, that's terrible. One train 300 from the station. That is worse.
You already have rain to the left.
Oh, you're right, it's over here.
Dread. Oh, that's what I.
300 from the station. The other train is 400, and yeah, we've got it here. So 300 is this distance. 400 is this distance. The trains are still moving, but they want to know at that exact moment how fast is this distance growing. So it is a related rate problem because they are giving you rates. The rate at which the green changes is v of a. V of a is how fast that distance changes. That's what a velocity is. The purple, how fast that distance changes, is this formula. They want a formula for how fast the blue changes. So the dread process says we do a Danicus chart. We write down all the rates that the problem talks about. Again, you've got to remember that velocity is the rate at which some position or distance changes. So I used the wrong color there. I should have used purple. So this purple distance, B, that's changing at a rate of dB dt, which is the exact same thing as the velocity of train B. Similarly, A here, this distance is changing at a rate dA dt, and that's the same thing as the velocity at time A. We're supposed to find dC dt. So the dread process says, we got Danicus chart, we've written down all the rates that we read about. We need an equation that will connect the rates. Sorry, connect the equation connecting the amounts. That's the E and the A. So that's Pythagorean's theorem. Once I have Pythagorean's theorem, I need to take the derivative of Pythagorean's theorem with respect to time. If you can get the red box, you've earned 2 points. Now all I got to do is solve for dC dt. You rearrange like this, and after that you plug everything in and don't do anything else. Just stop and collect one more point. You don't want to keep going. You don't have to. You'll just risk losing a point. I should have put units. They didn't ask for them. My experience is that they don't ask, they won't give you points for it. But a good habit is to have put units here. My meters per minute. Problem is worth a total of 3 points.